The second part of this lesson is about actually using the quadratic formula to find the solutions to a quadratic equation. Some of our answers will be real and some of our answers will be complex. Real solutions might have square roots in them, so we might have to simplify square roots, and complex ones might as well. So one way that I like thinking about the quadratic formula is instead of thinking about the whole thing, I think about it as basically the vertex formula, opposite of b over 2a, with the plus or minus the square root of the discriminant. We spent all last lesson looking at finding the discriminant, so taking the square root of that should be pretty straightforward. The discriminant breaks up the work of finding the quadratic formula in a really nice way. I'll show you how it works. So here's our first example. We're going to do this one together. We're solving using the quadratic formula, so we want to identify a, b, and c. And I want to really emphasize also that the quadratic formula only works if our equation is equal to 0. This one already is, so there's nothing we have to do to make sure that we can use the quadratic formula. So then we set our discriminant, which is b squared minus 4ac, being really careful about signs and parentheses. If we use exactly these parentheses, we can type this whole thing into our calculator as is. If we're not using a calculator, we would take -4 and square it, which means that it would become a positive 16. And then we're going to subtract a negative, because this 4 times 3 times 9 would wind up being a negative number. So it's 12 times 9, which is 108. And then that means 16 plus 108, and that is 124. Okay, now that's our discriminant. Now we can jump to that new version of the quadratic formula, which is the opposite of b plus or minus the square root of the discriminant all over 2a. Just simplifying a little bit, the opposite of b would be positive b. And so we have 4 plus the square root of 124 over 6, and 4 minus the square root of 124 over 6. The only thing left, like these are the answers, these are just not the simplified answers. The only thing left is to look at that square root of 124 and see if we can break it down and simplify it at all. So 124, we want to think about numbers that go into 124, and I know 4 does. 31 times, and 31 is not a nice number that's going to break up, but 4 has a nice square root, so we could think about it that way, or we could continue breaking up our numbers, and so 4 is going to be 2 times 2. And then if I look at just the ends of my branches of my tree, anything that is in the list twice has a nice square root, and the square root is that number. So this becomes 2, and then the thing that's left without a partner, that one has to stay inside. So I had a pair of 2's, that goes here, and the 31 didn't have a partner, so that goes inside. So if I rewrite this, I have 4 plus 2 root 31 over 6, and 4 minus 2 root 31 over 6. The only thing left is to kind of split it in two and see if I can reduce my fractions at all. So this would be 4 over 6 plus 2 root 31 over 6, and 4 over 6 minus 2 root 31 over 6. And these do reduce because 4 and 6 are both even, so if we divide by 2, we get 2/3. 2 and 6 are both even, so if we divide by 2, we get 1/3, and we'd still have a square root of 31 there. And the same thing with this version. Those are the two solutions to that quadratic equation. if I graphed this parabola, it would cross the x-axis at this point. The line of symmetry for this parabola would be 2/3, x equals 2/3. All right, here are a couple for you to try. So I'm going to encourage you to give them an attempt, pause the video, and then see my solutions. So you try first, pause now, and then come back. Solution to the first problem, I found the discriminant using b squared minus 4ac. I got a negative number, which told me that there were two complex solutions. Then when I put that into the quadratic formula, I was taking the square root of a negative number, which means that there's an I in my answer. I then broke up the 27 as 9 times 3, and the square root of 9 is 3, and 3, there's another 3 that has to be left alone. Then I split my answers into two different parts, 9 over 2 plus 3 root 3 over 2i, and 9 over 2 minus 3 root 3i over 2. So that is the first one, and I will go over the second one next. For the second one, I found that my discriminant was 529. And then when I put my discriminant into the rest of the quadratic formula, I wasn't sure how to break up 529 at first, and then I tried taking a square root on my calculator, and it turned out to just be a nice number. So since it was 23, which I got from my calculator, then I figured out 7 plus 23 over 12 and 7 minus 23 over 12. Work on reducing fractions here. So 30 divided by 12 reduces by 6. And 16 divided by 12 reduces by 4. So those are the two solutions to this quadratic. They are nice rational solutions. They can be written as fractions. The other twist to the quadratic formula is that maybe your equation is not equal to 0, in which case you need to fix your equation by moving the term over so that it is equal to 0 before you proceed. So this would be 2x squared plus 6x plus 3 equals 0. And I was very careful to make sure it looked like ax squared plus bx plus c equals 0 when I wrote it. And then I can identify a, b, and c. A is the number in front of x squared, b is the number in front of x, c is the constant term. When we figure out the discriminant, we do b squared minus 4ac and so then we put that into the quadratic formula, opposite of b plus or minus the square root of the discriminant all over 2a. And then I'm going to break up the 12. 12 is 4 times 3. 4 is 2 times 2. So if I take the square root of 12, I would have 2 on the outside times the square root of 3. So if I rewrite this as two separate fractions, it'd be negative 6 over 4 plus 2 root 3 over 4 and negative 6 over 4 minus 2 root 3 over 4. Those fractions all have even numbers, so they can all be reduced. Dividing everything by 2. Oops, I forgot to write that as a minus sign. So those are my two solutions to that quadratic equation. Just make sure when you do these problems that you set your equation equal to 0 before you proceed. I'm going to pause the video and have you try the second one. So make sure you pause, give it a try, and then I come back and watch that final solution. First thing I did was I moved my negative 2x over. I made sure to put that in the middle so I could really recognize that b is negative 2 because b is the number in front of x. I solved my discriminant. My discriminant was negative, which means that I'm going to have i's in my answer. I will have two complex solutions. So then I set that up in my quadratic formula, opposite of b plus or minus the square root of the discriminant over 2a. I split those into separate fractions, and then I realized that I have the square root of 80, so I broke up 80. I found two pairs of 2's and a single 5, so the square root of 80 is equal to 4 root 5. And then I did a little simplifying up here so that when I got my final answer, it would be simplified. Because I had 4 root 5 over 6, I turned that into 2 root 5 over 3. Tonight's homework will have you practice solving with the quadratic formula. Thanks so much. Bye.